Hey everyone, in this video we're going to take a look at solving this word problem about the population of India. And it says that the population of India was 1,173.1 million in 2010. The formula A of t equal to 1,173.1 times the exponential function of 0.008t estimates the population t years after 2010, and we're going to figure out what the expected population is in 2020. We're going to find when the population will be 1,377 million, and we're going to figure out when the population will be 1,491 million. Now, of note is this way that I've written the A of t formula right here, and this A of t is 1,173.1 times the exponential function e to the 0.008t. And writing it like this with the exponential instead of e to the is very common when you're writing this stuff in text, and it's very common to see it inline in text, exp, for the exponential function. Okay, so we're going to figure out what is the expected population in 2020. 2020, not 2000, 2020 minus 2010 is t equal to 10 years. So we are going to find A of 10, which is 1173.1 times e to the 0.008 times 10. And since I don't have a table for e in my brain, I'm going to go ahead and pull up my calculator. So let's see here. We'll take and we'll do 10. I'm going to store that as x in case I need to do more calculations, and I'll do 1173.1 times the exponential function 0.008x, and I get 1,270.8. So I guess we'll go to the 10th, 0.8, and that's our population in 2020. Go ahead, we'll write that down. What was that? 1,270.8 million. Great. Let's take a look at number 2 here. In number 2, we're not given the time, we're given the population. And that's going to be substituted in right here for A of t. So 1377, that's going to be equal to our 1173.1 e to the 0.008t. So I'm going to have to take this and I'm going to divide by this factor, so it's going to go on the bottom over here. So 1377 over that value, 1173.1. That's our equal to our exponential function. So that means we take the log of it. I'm going to take the natural log of this ratio, and that is going to be equal to the natural log of this, which is 0.008 t. So what's t? 1 over that, 0.008, times the natural log of this ratio. All right. And I'm going to have this be x in my calculator because that's the population. So I'm going to stick this into the calculator here. So that's 1 divided by, let's store that as x first. 1377, store that as x. So now I'll have 1 divided by that growth factor, 8 times the natural log of this ratio, x divided by 1173.1. Yep. Always worth it to double check. And we get 20.03, so we'll call it 20.0. So that means, when will it be? In 2010 plus 20 years, 2030. So then let's go over here. So for number 3, t will be equal to 1 over that same factor, the natural log of, in this case, what's changing is that top number, 1491, right? Over the same initial starting population. And t is going to be, in this case, I just need to take 1491, store that as x, go back into my history here, pull up that computation, hit enter, and I've got 30.0. So that means it will be in 10 plus 30 is 40, 2040. The population will be that size. Okay. So we used an exponential function. We looked at this new notation. We solved an exponential using logarithms. And then we figured out a neat trick in our calculators using the variables and storing the variable with this so that we only have to enter the big formula once. That's it for this video. Join me next time where we'll be doing more word problems.